You ever been in a really long chat with an AI, and all of a sudden it just completely forgets what you were talking about like 5 minutes ago? Yeah, it's a super common frustration. But it actually points to this fundamental bottleneck in how AI works. So today we're going to dive into something called FlashAttention, a breakthrough that, well, gives AI a much better memory.
Right, let's just jump into this. Why is it that the longer a conversation goes, or the bigger the book you feed an AI, the more it seems to struggle? It's like it has this kind of digital amnesia. Well, it turns out there's a very specific and very costly reason this happens.
So, you know these incredible models like GPT, right? They're all built on an architecture called a transformer. And for all their amazing power, they have this one critical flaw when you give them long things to read. It's a problem called quadratic complexity, and it is a massive wall they just keep running into full speed.
So what exactly is quadratic complexity? Well, to put it simply, for every single word an AI reads, it has to compare that word to every other word to get the full context. So think about that. If you double the length of a book you give it, it's not just double the work, it's 4 times the work. You can see how this just spirals out of control, right? It gets incredibly slow and eats up a ton of memory.
Now, your first thought is probably, okay, the problem is just the raw number of calculations. I mean, that makes sense. But what's really fascinating here is that the computation itself isn't actually the main reason these models slow to a crawl. The real culprit is kind of hiding in plain sight.
The real problem isn't the thinking, it's the reading. The true bottleneck is all about how the GPU, the AI's brain, accesses its own memory. It's this huge traffic jam happening on the data highway right inside the chip itself. And you know, the folks who wrote the FlashAttention paper, they just nailed it. They argued that everyone trying to fix this was missing one key idea, making the algorithm I/O aware. Now, I/O just stands for input/output, reading and writing data. So an I/O aware algorithm is basically just smart about how and when it moves data because it understands that every single trip to memory is expensive.
Okay, to really get this, let's use a simple analogy. Think of a GPU as having 2 kinds of memory. You've got HBM, which is like a giant library. It can hold everything, but it's pretty slow to go find one specific book. And then you've got SRAM, which is like your own desk. It's tiny, but anything on it you can grab instantly, lightning fast.
So the old way, standard attention, was just painfully inefficient. It was like running all the way to the library for one single sentence, bringing it back to your desk to read it, writing down a single note, and then running that note all the way back to the library to file it away, and then doing that over and over, thousands and thousands of times. It's exhausting just thinking about it.
And this brings us to the absolutely brilliant and honestly simple insight behind FlashAttention. What if, instead of making all those thousands of slow trips back and forth to the library, you could be way smarter about it? That's the core of I/O awareness.
So what it all boils down to is this. I/O awareness is all about cutting down on those slow trips to the big library. It's about designing an algorithm to be lazy in a really smart way. Do as much work as you possibly can on your fast desk before you even think about making another trip.
And FlashAttention does this with a really clever trick called tiling. Instead of grabbing one sentence, imagine grabbing a whole chapter, a tile, from that slow library. You bring that entire chapter over to your super fast desk, you do all your highlighting and note-taking and thinking right there, and only when you're totally done with that chapter do you write your final summary and put it back. The number of trips just gets absolutely slashed. Okay, so the theory sounds great, right? Super elegant, but does it actually work in the real world? Well, let's get to the results, because they are pretty dramatic. The numbers here are just staggering.
The results were, frankly, stunning. For a model we all know, GPT-2, FlashAttention wasn't just a little faster. It was a full 3 times faster.
And this chart really just puts it all into perspective. See that tall bar? That's the old way. And that little bar next to it? That's FlashAttention. I mean, come on. That's not a small tweak. That's a total game changer for how we train and run these models.
And it wasn't a one-trick pony. For another huge model, BERT Large, it gave a 15% training speed up from start to finish. Now, I know what you're thinking. 15% doesn't sound as wild as 3x, right? But you have to understand this was compared to a world record-holding system from MLPerf. That's basically the Olympics for machine learning. Beating the literal best in the world by that much is a huge deal.
But here's where it gets even cooler. It's not just about speed. Making the AI more efficient by letting it handle longer texts actually makes it smarter.
We see a big improvement in something called perplexity, which is really just a nerdy way of saying the model is less confused and more sure of itself. And for classifying long documents, it got a massive 6.4-point accuracy boost. It just understands complex stuff better.
So this kind of efficiency, it's not just about making the things we already do a little bit faster. This is one of those breakthroughs that fundamentally changes the map of what's even possible, and it opens up a whole new frontier for AI.
And this is really the key takeaway. Before FlashAttention, there were entire categories of problems that were just completely off limits to transformers. The memory and the compute costs were just astronomical. This breakthrough unlocked the door to tasks that need an AI to remember and reason over tens of thousands of things all at once.
Take these pathfinding challenges, for example. These are super hard. They require an AI to look at a huge, complex maze-like image and figure out if 2 points are connected. This means processing that image as a ridiculously long sequence of pixels. We're talking sequence lengths of 16,000 and even 64,000. With FlashAttention, these were the first ever transformer models to perform better than just random guessing on these tasks. This was thought to be pretty much impossible before.
So it all comes back to this. By fixing a fundamental memory problem, we haven't just made AI faster. We've given it a far more powerful and reliable memory. And that leaves us with a really fascinating question. From analyzing entire human genomes to writing a perfectly coherent novel from start to finish, what new frontiers is AI about to cross now?